go ahead and review for the Chapter 7 test review, okay? I'm going to do all these so you'll be prepared. Let's start with the first one. This is the measures of center. The measures of center all start with M, so we know that they're going to be the means, the median, and the mode. Okay, I think I'm going to make these fonts just a little smaller. All right, now let's list the measures of variation. Measures of variation are going to be the range and interquartile range. Better known as the IQR. All right. Yeah, I think it's spelled interquartile. No, they just don't know the reference here. Okay. Let's go. The next one says you survey 100 students at random entering the school about who plays a sport in your school. Is this a biased or unbiased survey? This is unbiased. And that's because you ask people entering the school, you have no idea who plays sports and who doesn't because you randomly chose the students. So there's going to be someone that plays sports and might say, hey, yeah, kids play sports in school, while some of them say no because they don't play sports. So it's totally unbiased. Number 4 says you ask students walking into the library if they like to read. You conclude that 60% of all students in your school like to read. Is this biased or unbiased? This, of course, is very biased. And that's because you're asking kids that are walking into the library. And most of the time, if they're going into the library, it's because they're going to get a book. They like to read. So, yeah, this would be a biased statement. If you want to ask people and it not be unbiased, you might want to pick people coming to the school or maybe in the cafeteria. Major League Baseball has 600 pitchers in the league. The data set represents a sample of 9 pitchers average strikeout per game. So let's find the measure of center and the measure of variation and find any outliers. Well, I'm going to say that 9 pitchers out of 600 probably is not a, it's probably not a good sample, but we're going to use this information to get this regardless. And the reason it's not a really good sample is because it's 9 out of 600. If you want to go ahead and get a good representation of the average strikeouts per game, you probably want to ask at least probably 100 pitchers, not 9. But let's go ahead and look at this really quickly. First, we find the median. To find the median, we got to put these in order. So I'm going to put these in order right over here. This is going to be, let's see, the lowest one is 2. The next lowest would be 4. The next lowest would be, looks like 5. The next lowest, we've got 2 6s here. After that, we've got 3 7s. And it looks like we've got 1 10. I'm going to call up all these 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9, just to make sure we got all of them. We're going to put a little space here in between each one of these to get a little work done. And now we're finding the median. To find the median, I want to find the one in the middle. Well, 1, 2, 3, 4, 5, 6, 7, 8, 9. Half of 9 is 4.5. Many of you realize that you can take the 9, go to 1, 2, 3, 4, then the 5th one must be the middle one. But we'll do it the way we did it in class. I'm going to take a highlighter and cross through each one on each side. Sorry, I wanted highlighter. So there'll be 1 there, 1 there, 1 there, 1 there. Remember, we're scratching off 1 from each side until we get to the middle. The middle has to be 6. So that's going to be my median. Now it says the inner quartile range. Let's see, inner quartile range can be found by taking the Q3 minus Q1. So let's write that formula down just to make sure we follow it. This is equal to quartile 3 minus quartile 1. And to do that, we have to find 1 and 3. I'm going to come over here once again and use my highlighter. And remember, now I've got 4 over here. I got to find the middle of 4. The middle of 4 is going to be right here at 2, right? Because if I cross one at each side, that's going to put 4 and 5 in the middle. So my interquartile range for this one is going to be here. And then for this 1, 2, 3, 4 over here, again, it would be between 7 and 7. I know to find the average of 4 and 5, I have to add 4 and 5 and then divide it by 2. So that would be 4 plus 5. That's going to be 9. Sorry, I put that as a division problem, didn't I? 4 plus 5 is 9. And then when I divide it by 2, I get 4.5. So this is going to be, quartile 1 will be 4.5. New quartile 2 is 6. Now quartile 7, or quartile 3 is between 7 and 7. There is no number between 7 and 7. So the number is 7. So now we got quartile 3, and we got quartile 1, and quartile 2. So remember, the formula is 3 minus 1. That's 7 minus 4.5. So I'm going to take 7, and I'm going to minus 4.5 here. I know I'm going to have to borrow 1. And 10 minus 5 is 5. The decimal point comes down. The 6 minus 4 is 2. So that means 2.5 is my interquartile range. All right. Next, it asks for the mode. The mode is the one most often seen. So if I look for the one that's most often seen, I put this in blue, I see that 7 is seen 1, 2, 3 times. That's the number that's most often comes up. So the mode is going to be 7. Next to the range. The range is the big number minus the small number, right? Big number, the biggest number in my data set, minus my smallest number. Well, the biggest number in this data set is 10. And my smallest one is 2, and 10 minus 2 equals 8. So my range is 8. Next, it says the means. This is a little more difficult. We have to add all of the numbers together and divide it by the number of numbers we added together. So I'm just going to go ahead and put these numbers together really fast. I got 10 over here, and then I got 3 7s. I know 3 7s is equal to 21, and 21 plus 10 is 31. So I'll just put 31 over here. And that took care of all my 7s and 10s. Next, I'm going to take 6, and I'm going to take 4. That makes 10. And then when I add 5, that'll make 15, and then 2 more make 17. So all those make, oh, I take it back. Hold on, I left out one of the 6s. Sorry about that. Let's scroll down. There we go. So that's going to be really, let's go ahead and put these together a little better. Okay, so that was 31. All this was 31. And I got 6 and 6 is 12. And then I got 5 and 4 is 9, plus 2 more make 11. When I add these together, I get 2, 3, 4. And when I add these together, I get 5. So that together, that's 54. All right. And I'm going to double check it using my calculator because I want to be really sure that I'm getting the right answer here. So remember, this is going to be 2 plus 4 plus 5, 2 plus 4 plus 5 plus 6 plus 6 plus 7 plus 7 plus 7 plus 10. That's going to, yep, it equals 54. Now I have to divide it by the number of numbers, which was 9. And 54 divided by 9 is going to give me 6. So the means is 6. All right, now let's go to outliers. The outliers formula, we had two formulas. One was Q1 minus 1.5 times the interquartile range. And anything smaller than that would be an outlier. We also have the formula Q3 plus 1.5 times the interquartile range. And anything bigger than that would be an outlier. So let's see if we have outliers here. Remember, Q1, we said over here, that was 4.5. I'm going to put that underneath here. 4.5 was Q1. And 7 was Q3. And that's how we got 2.5. So we could say now that we have this equals 4.5. Now we have to take 1.5 minus 1.5 times the interquartile range. And the interquartile range we said was 2.5. All right, so what is 1.5 times 2.5? Let's do that really quick. 1.5 times 2.5 will equal 3.75. So this is all going to equal 4.5 minus 3. Let me just double check, 3.75. Well, let's see, we got 4.5. We're minusing 3.75. We know we're going to have to borrow one, so we're going to turn this to a 4 and carry one here. 5 minus 10 is 5. We have to borrow one again. So 14 minus 7 is 7. Decimal comes down, and 3 minus 3 is 0, so it's 0.75. So do we have any number here lower than 0.75? No, the lowest number was 2. Now let's try this over here. This time quartile 3 we know was 7. So this should be 7 minus, and since I already know this is going to be 1.5 times 2.5, because it's the same as up here, this is going to be minus, let's see, we'll write it out for those who get a little confused here. This is going to equal 7 minus 3.75. I'm sorry, add, plus, not minus, plus 3.75. This, of course, make 10.75. All right. And that's, let's see, add that together. Yeah, definitely 10.75. We don't have a number bigger than 10.75, so we have no outliers. So outliers, none. All right, and that's it. All right, yeah, I think you guys are ready for the test. Good luck.